I guess most of us have seen a thrilling car racing competition. F1 players quickly go through a treacherous circuit that is composed of easy and difficult courses and return to the start line. The F1 racing track is intentionally made into easy or difficult courses, and it is similar to the electric circuit of a vehicle. An electric circuit is designed using several elements to apply the intended amount of current. From now on, we will compare the racing car to the current and easy or difficult racing courses to the electric elements. Current flows through the circuit that is connected to several elements. This circuit is similar to the F1 circuit. That is, the circuit through which the current flows can be defined as an electric circuit. Let's look at a simple electric circuit. Positive terminal of the power is connected to the lamp load through the switch and wires. Again, the lamp is connected to the negative terminal of the power through wires. Now, let's turn on the switch. Current flows to the lamp load from the positive terminal, and this current returns back to the negative terminal. In this process, the lamp turns on and heats up, converting electric energy into light and heat energy. More specifically, an electric circuit is designed to let the current flow and operate a load. If an electronic component, such as a semiconductor, is used on the electric circuit, it becomes an electronic circuit. An electronic circuit is embedded in the controller, which performs the role of the brain in an electronic device. An electronic system inside a vehicle can be constructed by connecting the controller, power, load, and other elements together. Let's look more deeply into the circuit on the vehicle. A vehicle is composed not only of an engine and transmission, but also of a variety of convenience, safety, steering, and braking devices. Each of these devices constitutes a circuit and operates with each other systematically. Therefore, a vehicle can be seen as a combination of many kinds of electric circuits. At first glance, an automobile circuit may seem rather complicated, but the configuration is not so much different from a basic electric circuit. An automobile circuit is composed of a power source, conducting wire, circuit protection device, current control device, load device, and ground points. Now, let's look at the configuration of an automobile circuit one by one. Different kinds of powers are used on a vehicle, depending on the vehicle power status. A 12-volt battery is the source of every power and supplies constant power, ACC, IG1, IG2, and start power to each electrical component. An accessory power is for supplementary purpose. ACC provides power to an audio or cigarette lighter, which does not require a large current. Ignition power is divided into IG1 and IG2. IG1 supplies power to the electric device that operates the vehicle starting and driving. IG2 is a general power used on most of the electric circuits, such as air conditioner and headlamp. Lastly, the start power supplies electricity to the start motor. Each load and power is connected through wires on the automobile circuit. Wires and circuit elements are connected through a connecting device called connector. The connector is used not only for connecting wires and circuit elements, but also for combining wires. The thickness of the wires differs depending on the capacity of the required current. For example, thick wires are used on the motor power, where large amount of current is needed. Additionally, there are different types of wires for special purposes. They are shielded wire that prevents electrical noise and twisted wire that is used on CAN communication. When excessive amount of current is applied on the automobile circuit, a protective device in the circuit protects the circuit and components. A fuse is widely used on the engine room and interior junction box. It melts when the current exceeding the rated current flows in the circuit, blocking the flow of the current. By doing so, it prevents excessive current from flowing through the circuit and electric components. Other protective devices include the fusible link that cuts off the battery positive mainline when an accident occurs, and the circuit breaker installed inside the motor to prevent motor overheat. A current control device is used to supply or block the current inside the circuit. A switch is one kind of current control device. A relay is also used to control the current flow and electrically turns on and off the switch by magnetizing the coil. We will learn more details about the relay circuit wiring on Module 3. Next, we are going to look at the load. Generally, a load consumes electricity that is supplied from the power fulfilling the purpose of the circuit. The lamp that produces the light, the heat wire that generates heat, and the rotating motor are the loads of an automobile electric circuit. A load on the circuit is ultimately connected to the negative terminal of the power. If every load is to be connected to the negative terminal of the 12-volt battery in the engine room, many long wires will be necessary. Ground points and body grounding are used to cope with this problem. The vehicle body is a conductor. There are several ground points on the body, and the negative terminal of the 12-volt battery is connected to the ground point near the battery. Also, the wiring of the load that should be connected to the negative terminal of the battery is connected to another nearby ground point. By doing so, the load and the negative terminal of the battery can be connected without using long wires. An automobile circuit that is composed of a power source, conducting wire, circuit protection device, current control device, load device, and ground points is needed for every operation on the vehicle, including lighting, air conditioning, seat ventilation, and driving a wiper motor. We can start the vehicle, turn on the air conditioner and lamp, and listen to music while driving the vehicle, all thanks to the circuit. Now, let's move on to the simulation and compose a simple lamp circuit. Click on the Simulation button. So far, we have learned about the configuration of an automobile circuit. What would happen if there is something wrong with the circuit configuration? For example, if a failure occurs on the lamp operation circuit, the lamp would not operate normally, and the driver would recognize this as a failure. From now on, we are going to look at the causes on the circuit side that create a failure on the vehicle. Cause for a circuit failure can largely be divided into open circuit and short circuit. First of all, open circuit means that a certain part of the circuit is cut. Due to this, the current does not flow through the circuit, and the relevant component does not operate normally. Causes for open circuit include melted fuse, faulty connection of a connector, and wire disconnection. Next, short circuit means that a certain part of the circuit touches another area and composes an abnormal closed circuit. Depending on the area where a short circuit has occurred, the load may not operate or operate when it is not supposed to do so. If a short circuit has occurred, overcurrent may be supplied, melting the fuse and damaging other components or wires.